So today we're going to talk about logs. Some people don't like logs. Oops, sorry, going back. You're going to find this to be easier. Why you're going to find this to be easier? If you don't find this to be easier, then I failed in my job. But you're going to find it easier, not because of me, but because this is going to be the second time you've seen this. Why was logarithms harder last year in Algebra 2 is because it was the first and only time you've ever experienced logs in your life. True? I've not seen an Algebra 1 class ever that they've got into logarithms in Algebra 1 ever. And so I'm hoping today this is going to be a little review for us, but at the same time, as we go through today, tomorrow, Friday, we're going to talk a little bit today. We're probably not going to graph it all today, so this graphing probably not going to happen, but we're definitely looking at some properties of logarithms today and set some of this up, okay? If you can pay attention today, today's going to be kind of an easy day, though, if you can pay attention. But I need us to understand what is a logarithmic function. Why is this important? So here's where it is. Number one. Logarithmic functions are functions, which means, what's that mean to be a function again? Every input has one output. Every x has one y. This is still going to be true here. Now, what a log is, though, and here's the significance of it, because some people are like, oh, this thing that's a log, this is so complicated. Look at this. I don't even understand this. It's like log, what, and all, all a log is simply this. And this should make sense because we've spent some time together with this, though. A log is a what? What's this word right here? You've seen it before. It's the inverse, but the inverse of what? The inverse of an exponential. We just talked about exponentials yesterday. Why? Because so today we can have a little better understanding about logs. And now this is, for me, I'm a visual person, so this to me makes sense. And I don't know if it makes sense to you, though, but we talked about inverses a couple chapters ago. And inverse is every x, I switch it with the y. Every x and y, I switch places with them. Graphically, this is what happens. Graphically, if I have an inverse, it gets flipped over this line right here, and that line is the line y equals x. When I switch the x and the y's, it gets flipped over this line. If you look at this closely, though, this right here, this is an exponent. E to the x, we're going to talk about e a little bit later, but e. Notice this exponent. It crosses the y-axis. This is crossing actually at, not at e, Mr. Roy, it's actually crossing at 1, because there's a 1 in front right here. That's my a value, 1. But this is crossing at 1. If I look at it, though, what's its inverse? This inverse is this guy right here. This is actually a log. We call this natural log. Or over here, we have 2 raised to the x power. It's crossing not at 2 because the a value is 1. It's crossing at 1 right here. What's its inverse? When I flip it over that line, it's actually this. It's log base 2 of x. A log is an inverse of an exponential. So logs end up looking like this. And I don't know if this makes sense yet, and I didn't really understand this until I took some graduate classes on this, though. But why do we care about logs in the real world? Mathematically, logs, as we're going to see tomorrow, allow us to do math that we can't do with any other type of function. But in the real world, though, if this makes sense, some people are always asking, why am I learning this, Mr. Roy? Why do I care about this? In the real world, right, I'm working for Amazon, I'm working for Google, I'm working for this big multi-billion, trillion-dollar company and stuff. Guess what? They're selling lots of things. They're making lots of money. A lot of the data that they're analyzing, sales here and there, their data is all exponential. They're looking at huge numbers, right? If I'm Google or I'm Amazon and stuff, and I'm looking at my numbers for different things, they're massive numbers. They're exponential numbers and stuff. Do I want to deal with analyzing trillions and billions and these huge, huge values? The answer is no, that's too big of a number to deal with. So what they do is they hire mathematicians, pay them a lot of money. But what a mathematician does is they take this exponent, this thing that's huge because it grows really quickly, they make it into a log. Because this log, it's growing, but it's not as big of a number and stuff. And they can do all the math and analyzing it as a log because this is a nicer number here. You can always convert it back to an exponent because you can go back and forth because these two things are related between the two. I remember taking graduate classes, and again, I remember we had this question we had to do, but the whole key was you had to switch everything into logs because that was much more doable to do mathematically, but you can always go back to an exponent. In real world, that's what businesses do, right? I'll talk more about that later. Today, this is going to be our bread and butter today. Write this down, circle this, highlight this, make this big. This is what today is all about. This is the definition of a logarithm. This is our definition. And I'll write it on the other board, but because I'm recording, I guess I'll leave it up here too. Though, we write down, and this is how our textbook writes it. They say log base a of x equals y. Then you have this little phrase in there. The phrase is if and only if a to the y equals x. In math, and some of you, even though you don't know it yet, you're going to do more math beyond high school math and stuff. And as you do more math in college and stuff, you're going to start to see this phrase. And the phrase if and only if, this is what Olivia was commenting on. She walked in here. Someone is. This is not Mr. Roy misspelling, but as you get older in other classes, you abbreviate this to IFF. IFF in math is the same phrase as if and only if. But here's what this phrase means, if and only if. It means if you have a log, this is a log, you can actually take this log and you can change it into a what? What's this over here? This is a function. What kind of function is it though? This is an exponential function. You can take this log and change it to an exponent is what this means. And the phrase if and only if means, guess what? I can go the other way, take this exponent and change it to a log. You can go back and forth between these two things because what are they? They're inverses of each other. This definition transforms logs into exponents, exponents into logs. And so every log can be written as an exponent. Every exponent can be written as a log. And that's really what today is going to look like in a second, is you're going to be converting one to the other because they're related to each other because they're inverses. Back a long time ago, because I'm old, and so I still say it because it makes sense to me, I had a student say, Mr. Roy, this is just doing the dab, right? Do you remember the dab? We were talking about this last period. Someone told me the dab was like way back in 2016 or something, like, right? I probably didn't learn it until probably 2018 because I'm always behind the game and stuff, learning new things and stuff, right? But remember the dab? The dab. You guys have been around the dab at least, right? They said it's just doing the dab. And what they meant by this, and this is Anna Koval. You guys maybe know Anna Koval, you know, her siblings and stuff, right? But Anna Koval was in class. She said, Miss Roy, it's just doing the dab. And right, she's like, what are you talking about, Anna, doing the dab? And she explained it to me, and it's like, this made sense. And so I shared it. And everyone's like, oh, yeah, it's the dab, Mr. Roy. The second hour said it's like 6-7, but I was like, well, I don't know, it's like 6-7, but that's second period. But anyway, but here's the dab. Here's what Anna said. She said, if I want to convert, what's the base of my log? The base of my log is, we say log base what? Log base A. What's the base of my exponent? A. What she was saying is, if I want to write this as an exponent, I take A, I raise it to the y power, see the y power, and then it equals what? I go backwards, it equals what? It equals x. So it's like you're doing the dab. You're going across and back over. You see it? And the opposite of this is, if going the other way, is if I start here, this is going to be log base A. So I start the base of this as A, but I do the dab again. It's log base A of what? Of x equals what? Y. That's the same thing we had right here. And we'll come back to this in a second, but I need us to convert logs into exponents, exponents to logs. I need us to see that a log is an exponent, and an exponent can be written as a log. Sure? I don't know. I said, because I asked them, I was like, they're like, well, the dab's old, Mr. Roy, and stuff, you know, and whatnot. And they're like, 6-7 is the new thing. And I'm like, so can you make this into 6-7 or something? And like, then they got into 4-1. 4-1, right? 4-1. Have you guys heard 8-2 yet? 8-2? I'm embarrassing Cody here. I don't know, but no, I don't know about 8-2, but it's what? Who did? Why? I know, Caden Brown. He's leading the trends and everything. So him and Ryler Parr leading the trends everywhere. So, but yeah, don't ask. Anyway, why am I recording this? Those of us watching this online, don't ask what's going on here. But anyway, this though, do we have it written down? Do we have this highlighted? Yes, yes. What's that? Well, this almost looks like a 7 here. I have no idea how they got 6-7. I have no idea. They just said 6-7 is the new thing now. I'm like, well, figure out a way that this is like. But I like the dab. Like the dab makes sense to me and stuff. But I don't know. Whatever. I need us to know this, be able to use this. So we're gonna come back to this in a second. Now, today though, before we come back to what really matters here, here's a slight little piece here. Logs themselves. One type of log is called a common log because it's the most common. And when they say common log, we're talking about log base 10. So this is saying this. If I have log base 10, it's kind of like this. If I have log base 10 of something. Because it's the most common of all the logs, though, and maybe remember this, we don't write log base 10. We just write LOG. Every scientific calculator, and you guys all have calculators sitting in front of you, you all have a button on your calculator that says LOG. That is actually log base 10. Do they write the 10 there? No. Just like this, if I wrote this down, what would you say this is? This is a what? This symbol is a what? Square root. Do I write the 2 there? No, we all know that I don't need the 2 there. It's just implied that's a square root. So when you see LOG, I need you to know that that's log base 10. I don't have to put the 10 there. That's just implied right there. Now, what I want you to see, and again, this is maybe silly and dumb and stuff, and this is not part of our homework and stuff, but every number, it doesn't matter what number. I just picked numbers. I should have picked 6 and 7 here, but I used 4, 7, and 23. I can write every number as a power of 10. And what I mean by that is like 4, and if someone has a calculator, 4 is really the number 10 raised to the, let me make sure I write this right. It's 10 raised to the 6021 power. And like, Mr. Roy, how do I know this and stuff? Anybody type this in real fast? 10 raised to this. Is it close to 4? Probably a little rounding and stuff. But why is it 0.6021? It's because what is the log base 10 of 4? What's that? If I type that in my calculator, what's that? Yes? No? Yes? If I typed in log base 10 of 4, that's that decimal 0.6021. Just like 7. I can write 7 as the base of 10. It's 10 raised to the, this one's a little bit bigger number, 0.8451. Why is it 10 raised to the 0.8451? Well, it's because what's log base 10 of 7? 0.8451. And again, I'm not going to ask you to do this, but I want you to see this, though, is every number can be written as a power of something. And I'm using 10 right here. And how I figure out what that power is, like 23, how do I figure out that power? In this case, it's even bigger. It's 1.367 or 117. How do I know it's this number? It's because the log of that number, base 10, is that number, 1.3617. But you can write any number at any power you want to. Conversely, and you're not impressed by this, but conversely, though, you can have other bases other than base 10. I can have logs of any base I want to, and so you can have other bases like base 2, base 3, whatever it might be, instead of base 10. And so, for instance, like I could take the number 3 and say, hey, 3, I can write this as a log, but I can say log base. What base do you want? Log base, I'll say 2, but log base 2 of what equals 3? Well, here's how I know. 2 raised to the 3rd power is what number? 8. So it's going to be log base 2 of 8 is going to be my answer. Log base 2 of 8, which we're going to see in a second, is a way to write the number 3. But you're like, Mr. Roy, I don't want to write it as log base 2. I want to write it as log base 3. Well, what's 3 as log base 3? Well, 3 raised to the 3rd power is what? 27. So log base 3 of 27 is actually also the number 3. You can write any number as a log is what I'm trying to show you, right? And I can write it as any base I want to write it. I want to write it as log base 2, log base 3. I'm not going to go a very big one here, but like if I went the next one up, log base 4, just because they get really big here. What's another way to write 3 as log base 4? Well, not 81. 64. And why 64? Because what is 4 to the 3rd power? That's 64. And so this is going to be log base 4 of 64 is going to be 3. And so as you see logs, I need just, number one, not to freak out, but just know that a log is just a what? This is just a number. You can write any number as a log, and you can write it as any base log that you want it to be too. And so logs are very, very fluid in terms of how you can write them, right? So when I see this, I can't freak out and be like, oh my gosh, log base 464, wow, what is that? It's just a number. What that number is, a lot of times it's a decimal number, but it can be any number that I want it to be. Does that kind of make sense or not? No? And not that that matters a whole lot. Here, actually, the last two things that matter. Go back to this. We kind of wrote this down. I kind of went out of order here a little bit. These are the two most frequently used logs. We talked about the one already. On your calculator, you have this button. We have the LOG button on the calculator. We just said this a moment ago. They call it the common log because why? Everyone that lives outside of America uses the metric system, and the metric system is base 10. This is log base 10. They call it the common log base 10. Again, when I see LOG, I need to know it's base 10. The other log that's on every calculator that's scientific is not LOG. The other one, you may remember this in Algebra 2, is this guy. It's LN. That's the other button on our calculator. That is the other most common log, and that actually is what's called a natural logarithm. I don't understand why they use LN. Why don't they say NL? These are questions I have, right? Natural log NL. Why do they say LN? Anyway, whatever. I didn't make it up here. I'm just trying to share with you. But this, though, when you see LN, though, this is another log, but this is log base what, though? It says on the board, but what is it, though? Kind of a weird one. Log base E. E is the most forgotten number in mathematics here, but probably one of the most important numbers in math. And like E is forgotten because all of us know this, and we all know this number. If I said this number, well, this is a Greek letter. The Greek letter is what? Pi. If I said what's pi, a lot of us could spout out at least the first couple digits of pi. What is it? Right? I mean, we know pi. How many of us know what E is? This is log base E. What's E? Anybody know that number? No love for E? Cody? 2.7? But this is also an irrational number, goes on forever, but most people don't know this one. Why do we celebrate Pi Day, March 14th? Why don't we celebrate February 7th? I think maybe this year we should celebrate February 7th in this class, E Day, because it's a number and it's actually significant because ln is log base E. And as you will learn throughout the rest of this year, Kayla Albright's here, so she can agree with me here if she wants to. What's the only log that you can derive and anti-derive? It has to be what kind of log? A natural log, she said with confidence. The only log that we're going to be able to derive or anti-derive in calculus later on is natural log. So everything we do is going to have to be converted into natural logs. We'll talk about how to convert it into other logs tomorrow. And so log base E is going to be important. That's why this is on there. Those of you that don't know, this is kind of cool. So this is not important, but I think it's kind of cool. The number E is like pi. It goes on forever. 2.71, yum, something, 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 something. I should memorize more of it. But it comes from this formula. It's kind of neat. The formula is this. This is actually the number on your calculator. See the divide sign on your calculator? If you hit shift in the divide sign, I think that's the number E. You see the little E on there? This is what your calculator is going to say when you have E to the first power. But this is the formula for E. Take a look at this thing. Who came up with this? This is kind of sweet. This number, which again has to be used, the only thing we can drive and anti-drive in the world of logs, log base E, this irrational number, comes from taking 1 plus 1 over 1, that's 2, plus 1 over 1 times 2, plus 1 over 1 times 2 times 3, plus 1 over 1 times 2 times 3 times 4, plus 1 over 1 times 2 times 3, 4, 5. You keep adding a smaller fraction to this every single time. Will this number ever end? Because this is constantly adding another fraction. It's just that each time I add another fraction, it keeps getting smaller and smaller and smaller. But it makes this number E, which shows up again, natural logs, log base E, is actually this number when you say the number E. Crazy. Kind of cool. Now, here's what really does matter. Let's go back to what matters. All this stuff, yada, yada. This is what matters. This right here, right? We wrote this down. You ready to play the game? This is today. So pay attention to this. See if you can do this. You catch this. This is going to be the easiest assignment of the year if you get this, right? Some of you are going to laugh at me and say, this is all we're doing in pre-calculus today. Yes, because I need us to understand every log can be what? Can be an exponent. Every exponent can be a log. You can go back and forth between the two by using this. So here's the question today. Boom. They're going to ask you, and I think it's in this order, actually, the first so many questions. They're going to say, here is a what? Log or exponent. What's up here on the board? This is a log. All they want you to do is change this log into an exponent. Do I understand the DAB? Do I understand the 6-7 if you're in second hour, which I don't understand yet, but whatever. But could I take this log, write it as an exponent? And again, once you see this, you're like, this is it, Mr. Roy? For the most part, yeah. What's the base of my log? Base of my log, that's where I start. Base of my log is 4. So the base of my log is 4. That's the base of my exponent. The bases are the same. But then I do what? I take 4 to the second power. And that's going to equal, if I go across the sign back to equals what? And again, is this a true statement? Yeah, and not that even matters, but this is now an exponent. I just changed this log into an exponent. See how easy that was? Your turn. Log base 3 of 81 is 4. What's that look like as an exponent? Cody's not even writing this down. Cody, just humor me a little bit. You're sitting in the front row. You got to humor me now. Come on now. What's this as an exponent, though? What's the base? The base is 3. So this is going to be 3 to the 4th power equals. We get this? We got this? Every log is an exponent. We got this? Yes? Can you go the other way? Other way, Mr. Roy. Other way is this. What if you have this? This is not a log. This is an exponent. Can I change this exponent into a log? So again, what would this look like? Again, I'm look a little different again. What's the base of this? The base of this exponent is 6. So when I use that definition, and sorry, normally I write this behind me, and maybe I should, but since I'm recording here, this is going to say log base 6 of what though? 216 equals, go across my sign, equals 3. That makes sense. I like the dab, right? Anna Koval, that was kind of clever, right? Honestly. So if you see Anna Koval, tell her, hey, we're still dabbing because you taught Mr. Roy to dab. But anyway, this works. What about the second one? What would you say here? A little bit different. You have negatives in here and fractions in here. But this would be log base 2. So base here is this. So log base 2. So I just put that there. Of what, though? Equals. If you have a log of a fraction, you're going to get a negative, is what you'll see as we do more with it. Do you feel like you could do this? 2/3 of the assignment is this. I'm not lying, right? So can I go back and forth? And you're going to do lots of reps, but is it going to take a long time? This is going to go kind of quick. If we don't get most of this done in class today, then shame on you. Now, the other part of today, here's the other part of today. This is kind of the same thing. They're going to say, tell me the value of this log. And I'll be honest with you, there's a button on most of your calculators now that does this for you. But I'll be honest with you even more, when we take our test, you're not going to have a calculator for this. And so you're going to need to know how to do this without a calculator, even though there is a button, and I'll show you that button tomorrow. If I want to know, this is a log. If I don't know how to find the value of this log, you're like, I don't know what log base 5 is 125 is. And some of you know because you kind of get what's going on here. Then this is what I would ask you is go back to the definition. If you are stuck here and I know a log, change it into an exponent because you can change every log into an exponent. So if I do this, I have a log, I want to change this to an exponent. The only thing I have to do is I need to set this equal to something like x, y, z. Set it equal to something. So for me to dab this out, I need to have it equal to something. How does the dab work though? If I don't know the value of this, what's the dab say? What's the base of my log? 5 raised to what power? X equals what? Now, you still might be looking at me, Mr. Roy. I don't know what this is now because x is in the exponent. But if you can be clever with this, what's the base here? The base is 5. Is there a way that I can write 125 as a base of 5? What's 125 as a base of 5? 5 raised to what power is 125? 5 times 5 is 25. Times 5 more is... So 5 to the what power? Third. Again, if I can be clever and think of this, what's another way to write 125? It's 5. If these are the same base, then what's x going to be? 3. So my answer here ends up being 3. So what's the value of this log base 5, 125? It's 3. Does that make sense? What's that? Jesse said that's more work, right? I know some of us, you can just look at this and see what the answer is. I get it. I got it. Be patient with me. But this will always work for you, especially as you get to other ones. What would you say this is? What's log base 2 of 32? Well, all right then. If you can see it, good for you. If you can't see it, then change my log into an exponent. So as an exponent, what is this? But I have to set this equal to something. I have to set equal to x so I can dab it out, though. As an exponent, again, this is what to what? I'm losing some of you. Go hang in there with me. We're almost done. This is going to be... Gabe, as an exponent, what's this as an exponent? What's this as an exponent? 2 to the x equals 32. Now, why am I doing this again? This is base 2. Is there a way to write 32 as a base of 2? 2 to what power is 32? 2 to the first, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. So this is actually going to be 2 to the fifth, which Samantha said from the beginning, what's x supposed to be? What's the value of this? X is 5. Sure? We're all right here? Last two problems. This one, and then I threw this in here just because this is more like your homework here. And then one other example here. And I'll let you free here. If I asked you this question and said, write this as an exponent. Again, kind of going back to what we did a moment ago. How do I write this as an exponent? This is a what right now? This is a log. And in particular, Olivia just said, if you don't see this, I need this. When I see ln, I need to be thinking in my mind. You don't have to write this down, but in my mind, at least think this. This is log base what? E. So in my mind, I need to be thinking this is log based E of 4 equals 3W. If that's the base, how do I dab this out? What's this as an exponent? This is just e to the 3w equals 4. So I'm just taking this, raised to this, dab it out. And this is going to be my exponent. Does that make sense? Again, if I see ln, don't freak out. Just log base e. Last pieces. Is this okay? This is not horrible, is it not? Evaluate this for me. This is weird looking. And again, I put this on here because I think on your homework there's kind of some weird questions like this too a little bit. This is everyone sees the log. Obviously, we have log base 7 to 39. But if you look closely, though, this is actually, even though there's a log there, this is actually what, though? This is a 7 raised to this log, right? 7 raised to this log. This is really an exponent here. Do you know the value of this exponent? 7 raised to this. Do you know the value of this? If you don't know, what's the definition tell me to do? If I don't know what this is as an exponent, can I change this to a log, right? And do you see the exponent here? Do you see the exponent? We have 7 raised to something. That's my exponent piece. Again, how do I change this into a log if I get stuck here? Well, maybe I put an x over here. Take me through this. What's this look like if I dab this out? As a log, this is going to be log base 7. So if I write this out, log base 7 of what? Of x. Dab it out equals what? What is that whole thing up on top? Right? If that's the case, what's my answer? Right? Because log base 7 of x equals log base 7 of 39. We're talking about a property here tomorrow with this, but this is just 39, my answer. But again, this is, if I see this as an exponent, you can change it to a log, which again, it looks weird, I know, but seeing it that way. One last one for all of you that think you got this all figured out and this is too easy for you, then here it is. Make this a little bit more fun. What's this without my calculator? Log base 9 of square root of 3. What do you think? What's the value of this? This, if there's going to be anything that's going to be kind of challenging, this is a little more challenging here. We got to think about a few things. We got to know a few things here. As you see here though, but again, this is a what? This is a log. Do you know the value of this, top of your head? If I don't, now what can you always do though? Definition of a log says I can take this log, which I have no idea what the value is, and do what with it? Change it to an exponent. Can you dab it out? What's this as an exponent? And maybe even change this to an exponent. It doesn't make it easier. I don't know. There's still some work we have to do here. This goes back to yesterday. What's this as an exponent? 9 to the x. So 9 to the x equals square root of 3. Maybe that doesn't help me, Mr. Roy. That still looks like a mess. Does anybody see what we can do with this, though? There's potential with this, though. 9, Jesse's saying 9 is really what number? 9 is 3 squared. Is that true? 9 is 3 squared. If I write this as a base of 3, this is really 3 squared. So 3 squared to the x power. Or if I want to, again, powers to powers, what do I do with powers to powers? Multiply. So this is really 3 to the 2x is what I have on that side. Now the other part we have to know, this goes back to yesterday, and again, yesterday, we got it, Mr. Roy, but now do we really get it, though? What's another way to write the square root of 3? That's really 3 to what power? This is, again, there's an invisible 2 right here, right? 2. This is really 3 to the first power. This is really 3 to the 1/2. So if I see a square root, that's really meaning this, 3 to the 1/2 power. This is the key, though. I want to write both these as the same base. This is 3 to the 2x. This is really 3 to the 1/2. If you have them as the same base, what can I do to get my answer? I just set the exponents equal to each other. So what do my exponents say? 2x equals 1/2. What's my answer? How do I solve for x? Divide by 2. What's 1/2 divided by 2? Right? Or I could, instead of divide by 2, multiply by 1/2. What's 1/2 times 1/2? That's another way to do the same thing. My answer is going to be 1/4. That's a little bit tougher, yes? But the key, though, Jesse kind of led us this way. Can I write these as the same base? I got to be kind of clever. Square root is really to the 1/2 power. This is going to be 3 to the 2nd or 3 to the 2x. I don't know. That's about as hard as some of the questions are going to get. So that's a little bit tougher. But a third of the problems are going to be this. Or probably 2/3 of the problems are going to be this. Can I write them as logs? Can I write them as exponents? Yes. Can we all be happy today? Because this is not going to be horribly bad. Now, here's the only bad news. I'll warn you. We won't have to worry about this. But these questions again, I'd like us just do the odds, right? If you want to do all of them, go for it, more practice, but just at least the odds here. Before you complain, though, and say, Mr. Roy, these go really, really quick, but I will warn you. Some of these questions are going to ask you to do A, B. So there's like 2 questions in one. There's a few of them that's A, B, and C. But do these take a long time? Some of these don't take a long time. I really think, oh gosh, look at the clock here. I bet you could probably walk out of here with most of all of this done. Honestly, because tonight we have busy nights tonight. We have to go play golf tonight. We got to go to practices tonight. Some of us have to go to work tonight. Some of us have to babysit a 5-year-old and a 3-year-old that are just mean tonight. I don't want to be thinking about doing this later on tonight. Some of us have godparents. We got dinners to make tonight. We have dishes to do tonight. You guys do jobs around the house or what here? No, yes. Please say yes. You help your parents out. Right now, so far, tomorrow there's more of the world of logs. But right now, I need us to understand just the definition.